verify that e raised to 2t and e raised to negative t are both solutions of the differential equation. Okay, so this is our y, and we plug that y in here and get 0 in order to verify that's the solution. So for a, let y be e raised to 2t, then we plug this into the left hand side, and if we get 0, then yes, this will be a solution. To plug in here, we need to find y prime derivative. So derivative of e2t exponential function itself times derivative of 2t from chain rule. So this is in fact 2 times e raised to 2t, and we need to find second derivative as well. So let's find the derivative of this. 2 is already there, and e raised to 2t, like last time, we get 2 times e raised to 2t. So 2 times 2, 4 times e raised to 2t. Now left hand side of the differential equation is y double prime minus y prime minus 2y, which is y double prime is 4 e raised to 2t minus y prime, that's 2 e 2t minus 2 times y is e raised to 2t. Okay, negative 2, negative 2, negative 4 e raised to 2t, positive 4 e raised to 2t. So these two collectively cancel with this, so we get 0, which is the right hand side. So e raised to 2t is a solution. So we can say this implies e raised to 2t is a solution. Similarly, we can try for the second function, e raised to negative t. So let y be e raised to negative t, then we find first derivative and second derivative in order to plug in here in the left hand side. Okay, y prime derivative of e raised to negative t itself times derivative of top. Derivative of negative t is just negative 1. So negative 1, let's put in the front, negative 1, we don't have to write, negative 1 e to the negative t, and second derivative will be, let's find the derivative of this. Negative is there, and derivative of e raised to negative t, that will be negative e raised to negative t. So negative negative positive e raised to negative t. Now the left hand side of the differential equation, y double prime minus y prime minus 2y, which is equal to y double prime is here e to the negative t minus y prime. Y prime is negative e to the negative t, this minus and negative plus e to the negative t minus 2y, and y is e raised to negative t, which is e raised to negative t plus e raised to negative t, 2 copies, 2 e raised to negative t minus 2 e raised to negative t, so that's 0. So we get right hand side. That means e raised to negative t is also a solution, or in fact we verified is a solution. In part B, okay, in part B we let c1 and c2 be any constants, and we need to verify c1 e raised to 2t plus c2 e raised to negative t is a solution of the same differential equation. This is in fact a linear combination of these two solutions. In part A we just showed e raised to 2t, e raised to negative t individually. Okay, they are solutions. Now part B wants us to find their linear combination, where c1 and c2 are any constants, arbitrary constants. This linear combination is also a solution, and in fact what we are trying to prove here is, if we have two solutions, then two solutions, then their linear combination is also a solution, and this equation is called homogeneous linear differential equation. Homogeneous means right hand side 0. Okay, so this is our y for part B. Let y be c1 e to the 2t plus c2 e to the negative t. To plug this into the left hand side of the differential equation, we need to find y prime and y double prime. First derivative c1 is constant, just c1. E raised to 2t, derivative is e raised to 2t times derivative of 2t, 2. So I'm going to put on the front, plus c2 is c2 e raised to negative t itself times derivative of negative t, which is negative 1. So negative 1 I want to put in the front. In fact, negative 1 plus, that's negative sign. So negative 1 plus, this is just a negative sign. Y prime, and let's find second derivative. 2c1 constant itself, and derivative of e raised to 2t is itself times 2. So 2 to 4 c1 e raised to 2t, c2 is there, e raised to negative t itself times negative 1, and this negative positive e raised to negative t. Now we are going to plug these into the left hand side of the differential equation. Now the left hand side, what is the left hand side of the differential equation? That's y double prime minus y prime minus 2y. Y double prime minus y prime minus 2y, and y double prime we found here. So 4c1 e raised to 2t plus c2 e raised to negative t minus. So whenever we see minus, then we need to put parentheses around, because we need to later distribute this negative 1. Minus y prime is here, 2c1 e raised to 2t minus c2 e raised to negative t minus 2y. Minus 2, again we need to put parentheses around, because we need to distribute this negative. We did not care in the for the first term because there is plus 1 and it does not change any sign. So minus 2y, y is here, c1 e raised to 2t plus c2 e raised to negative t. Let's copy this, e raised to 2t plus c2 e raised to negative t. This is negative 1, and we need to distribute. So negative 2c1 e raised to 2t, negative negative positive, this is c2 e raised to negative t. Again we need to distribute negative 2, and we get negative 2c1 e raised to 2t, negative positive negative 2c2 e raised to negative t. Now we can combine like terms, e2t, c1 e2t, c1 e raised to 2t, this, and here negative 2c1, negative 2c1, negative 4c1, and positive 4c1. So this one cancels with these two. In the same way, c2 e negative t, c2 e raised to negative t, 2 c2 e raised to negative t, and that's positive, 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 and is negative. So this one collectively cancels these two. Okay, so we get 0. That's the right hand side of the differential equation. Okay, so good. That means we verified c1 e2t plus c2 e negative t is also a solution, and in fact this is a linear combination of these individual solutions.